Alright, so this video is talking about marginal analysis. So marginal analysis is a technique that can be used with all mathematical models. In linear models, it is done by closely examining the slope of the model. In later lessons, we are going to be doing calculus and learning about the derivative, which is the slope of the tangent line. So please don't freak out. I know I just said calculus, but you're going to be able to do it. I promise. So back to this. Marginal analysis is the study of the rate of change in economic quantities. The slope in a linear model is the rate of change. A decision maker may not only be interested in the cost of manufacturing, but interested in how the cost changes with respect to the level of production. We always want to know that because our supply costs and our labor costs change. They're dynamic, they're fluid. So life is not linear. And we're going to learn that in the next section. So marginal analysis supports decision making based on marginal or incremental change to resources, land, labor, capital, information, know-how, management, etc., instead of one based on totals or averages. Right now, in the linear case, we are worried about totals and averages. After the midterm, we're going to start building towards something called marginal analysis, and we're going to look at it in the quadratic and the cubic world, where it more accurate I can speak accurately reflects real life. So specifically, marginal cost is the change in total cost of producing one unit at a particular production level. Marginal revenue is the change in revenue of selling one more unit at a particular sales level. And marginal profit is the change in profit of producing and selling one more unit at a particular sales level. The rate of change of any quantity may be taken. Some examples include output depends on capital investment. Then we can determine how output changes with an incremental change in capital investment, say for each $1 million. If output depends on the number of workers, then we can determine the output changes with the addition of one more worker at any level of workers that we have presently. If the number of cellular subscribers depends on the year, then we can determine how the number of subscribers changes per year for a particular year. We will learn how to do this more in section 5 with how to do correlation. Now, the bottom line here is, and as business majors, you always want to know about the bottom line, right? We can, and science majors, social science majors, when you're doing research, you're going to have to, defend your bottom line. What are you trying to find? We can take the rate of change, marginal analysis, of any mathematical model, no matter what it describes. Okay, we can figure that out no matter how big the model, no matter how big the degree of the model is. So if we look at an example, the total cost equation for a certain product is C equals 14x plus 3,000. We want to find the marginal cost and interpret. The marginal cost is the $14 per unit. No matter what the production level is, the cost is increasing by $14 for each additional unit produced. This is a linear equation. The rate of change of a linear equation is constant and is the slope. Thus, the marginal cost is $14 per unit, no matter what the production level is. When we get into quadratics and cubics, we're going to be taking something called the derivative and finding the slope of something called the tangent line. And that will be how it's changing in that moment, not overall. Right now, we're looking at overall. We really need to get into the moments. So the profit equation for a certain commodity is P equals 22x minus 560. Find the marginal profit and interpret. Marginal profit is the $22 per unit. That is the slope. That's the mx plus b. Remember, recall. Let me make sure that this is a pen. Y equals mx plus b. Slope is 22. No matter what the sales level at the company is at, profit is increasing by $22 for each additional unit produced and sold. Okay?